Perseverance lands and begins its mission to explore the Red Planet. The European Space Agency is on the hunt for new astronauts 11 years since its last search. And the first black hole ever discovered is bigger than thought, thanks to Aussie astronomers. It's Tuesday, February 23, 2021.
On Apple Podcast, Spotify, Google Podcasts, and YouTube. With the latest science and space news, this is Talkin Science with Dr. Brad Tucker and Matt Miller.
Welcome to Talkin Science. Matt Miller with you for another instalment of the science and space news. Dr. Brad Tucker is here. Brad, happy Tuesday.
Yeah, how's it going?
Really good, really good. A big week in science and space. The culmination of 2 weeks of Mars missions happened on Friday.
Yeah, look, it was nice to see it all work and it'll get there arriving. And so now the fun really starts.
Absolutely, and we're going to get into that on our stories of the week. But before we get there, a quick reminder of the socials. We can find you on Twitter at btucker22. I'm on Twitter at Miramat86, and of course Trekzone exclusively on Twitter now at Trekzone.org. Plus find our YouTube channel for the latest eps. And we're also on your podcast app of choice. Brad, first up in our headlines, RocketLabs has set their next launch window for mid-March. They go up so fast. I love that name. Will take 3 Aussie CubeSats as well as their next-gen spacecraft.
Yeah, it's always quite interesting with their naming scheme, so to speak. It always makes it a bit of fun. But as you said, they have Mariota, the M2 Pathfinder, which is a UNSW Air Force satellite. Coming up, so it's really exciting to see some of these actually coming into fruition, and RocketLabs is getting quite good at turning around these missions quite quickly, which is something that they've obviously worked hard at doing.
The Aussie Space Agency has signed a memorandum of understanding with the Indian Space Research Organisation, the country's space agency. This is going to see greater cooperation and collaboration between our countries.
Yeah, look, there's been a long history between India and Australia in terms of space, and there's been a lot of conversations I've had even on this area of how can we grow with it. They're a growing space power, one of our nearest neighbors, and we're also quite complementary in terms of our goals, our expertise, our science. So it kind of makes sense. So again, it's great to see Australia getting out to do some of these international partnerships to be a part of some of the upcoming projects, not just with NASA, but all around the world.
And lastly, in our headlines, a quick plug for this week's Talkin Science interview, the new show that we're doing on Thursdays to go in depth with the movers and shakers of science and space news. Dr. Matt Owers will be here talking all things SAMI survey. We covered this a couple of weeks ago on Talkin Science, the news show. It's the ambitious study of over 13,000 galaxies.
Yeah, Matt and I have worked on other projects, one called Aussie, so it's great to be able to see some of the workhorse science that's coming out of the big facility at Siding Spring, the AAT.
All right, Brad, into our stories of the week now, and Perseverance has landed on Mars, wrapping up a 7-month voyage.
Look, it got there. That was the trick. It's not always a guarantee it's going to get there. And I don't say that lightly. They don't always get there. They don't always make it. The current percentage now is 54%. So of the 49 missions, now 26 have been successful, completely successful getting to Mars. So it's not a guarantee that it just works flawlessly, but that's what happened when we saw it on our Friday morning.
And as a special treat for 2021 Talkin Science viewers on YouTube, we've been sticking with images from the stories that we've been covering, but this one's so special that I'm running the NASA video that they released this morning of that landing from all those cameras. It's the first time that we've seen landing on Mars in such detail and with so many cameras on board.
Yeah, look, and I think that's the thing is they've never really caught the descent like what we're seeing. You know, anything that we've ever seen has been photos once it made it on the surface, the animation of what we know is going to happen. some photos or some imagery from space. We have seen previous landings from space as the probe or the craft was ascending. Never this onboard landing footage. It's a lot like the cameras on airplanes. So when you're flying, you can see what the view is from the cockpit or the tail. It's pretty remarkable to be able to see it, but also it's actually quite already a bit useful in terms of demonstrating some of the difficulties you're talking about. You can see how the parachutes are acting relative to that Martian atmosphere, which is a lot weaker. The fine dust coming off the surface. So quite a bit you can actually understand from seeing this video.
Now, there was a little concern over the weekend about the lack of transparency from the agency. We talked last week about NASA's openness and ability to access the imagery. I spotted some professionals in the field venting their frustration a little bit on Twitter about the lack of raw data on the website. I'm just wondering whether that was all because of all of these cameras, so much data to process in anticipation of this press release this morning. Do you think that's what it was, a bit of a lag in the processing, or maybe a change?
It's a bit hard to say. The Perseverance has the most receivers and the highest bandwidth ability to send of any mission. So that includes direct point-to-point, so from that rover to Earth, and also via reconnaissance orbiter, using the reconnaissance orbiter as a relay as well. And that's a bit why a lot of people were saying it's a bit surprising that they haven't released it. Usually the flood of at least raw imagery, it does take time to process the photos and videos. There's a lot to it, but usually the data download dumps essentially are always usually public, so people can sweep through and see are there any nuggets that they would like to talk about or write or just understand. So they haven't really fully said why that was the case. Maybe they're just waiting for the first videos to talk about it, and then we'll kind of do these data download dumps. I think there's a lot of in the community when we've looked at other missions, and again, this is my work on the Kepler Space Telescope, it is pretty much open access across the scientific circles and the public, if they want it as well, if they can understand it. Some of that data is a little bit more obtuse than seeing just photos and videos from Mars. So I think it was more so a worry that this isn't going to be the norm, hopefully, that there was some sort of special circumstance that they were just getting ready and that sort of thing. So we'll see how it unfolds out over the next couple of weeks, especially now that the first press conference has happened about what it looks like, what happened, and that sort of thing.
We have been seeing images from the hazard avoidance cameras, and as I learned, they really want to see those before they start commanding the rover to go anywhere, making sure that it's on solid ground, that it's all stable and ready to go, and there's nothing around that's going to upset it. And we've also been getting telemetry from the helicopter as well, so every box is being ticked in the positive with this mission.
Yeah, they just don't start going right away. As I said, they do their checks. The battery for the Ingenuity, I think, was charged to about 35%, and then they'll do some slow charges weekly. Again, not to overload the battery in the system, to really get it up to working before they have that flight. I think they were planning a nominal lifetime of 3 months for the helicopter to get it to work. So, easing it in, you don't just turn it on and start flying, making sure really that it can handle the environment, because part of this testing is, does this technology just work on Mars? So, does it recharge? Does it boot up? Does it batteries in a state that actually can keep the electronics and the flight systems going? So all those are little processes you ramp up, so you don't go from 0 to 100 overnight.
All right, Brad, next up, ESA is on the lookout for its next class of astronauts 11 years after the European Space Agency last conducted a search.
Yeah, so it's been quite a while since ESA has put out the call for astronauts, but in this latest one, they are really looking for not just the cream of the crop as you normally think. Obviously, that's who they want, but really emphasizing a wider range of astronauts, really more diversity, and not just in the sense of saying, "Hey, let's have more diversity." Realizing that in the past they haven't done as well with getting female astronauts in particular. And at the same time, space is changing. So some disabilities are no longer a just reason to say you can't go into space. And this is just long overdue. and it's great to see ESA getting on the ball and addressing it.
Yeah, absolutely. The para-astronaut or the parastronaut, I reckon it is, feasibility project is part of this class. And we're going to see, as you say, we're going to start seeing people with disabilities given the same opportunities to travel to space. And they're focusing on lower limb disabilities because obviously you don't need to walk in space. So that's not a hindrance, as you say.
Yeah, it's kind of one of these cluey things people realize that, that's fine. Like, it works. You're floating around. I mean, there's actually even scientific interest in understanding what it also does to the body in space. So from an understanding of space travel standpoint, really useful for, and again, this is the same thing, same argument with female astronauts. A lot of the studies have been done primarily from white male American astronauts in particular. That has been the dominant study. That is not representative of the populations of humans. So you need to change that. And we saw with the last NASA astronaut class, it was pretty much 50-50 male-female. I think they may have had one more female astronaut than male astronaut. So definitely a big change in how things used to be, say, from the 60s, long overdue. And as you said, with the lower limb issues that someone may have, it just doesn't affect you. So it doesn't matter. And even when you land, they keep you sitting, because if you stand up, you faint because there's an imbalance with the way blood is moving your body. So, like, there's just no reason. So it's glad to see they're realizing there's no reason.
Now, you're a very busy man because, as we keep saying on Talkin' Science, science never sleeps. There's so many emails going
yelling
through.
At me. A gamma ray burst has just gone off, and people are wondering why my computer is going. Gamma ray bursts go off all the time. So now Swift has been triggering on this, so you get updates about, is it seeing something or not? So it's visible in the southern hemisphere, hence why I'm getting pinged about it. But it's also daytime right now as recording, so I can't really do much for another 12 hours.
Well, back on to ESA's hunt for astronauts. And as we talked about, women are going to be a big part of this class of astronauts. ESA has only sent 2 into orbit so far.
Yeah, look, obviously ESA has sent a lot less astronauts than, say, NASA and Roscosmos, given that NASA and Roscosmos have been the bulk of the flight launching. So they get the highest number of astronauts up. So, in fact, some people forget that the first UK or British astronaut was Helen Sharman, so a female. And then they obviously had Tim Peake, who was, I think, the first government-funded UK astronaut, if we really want to get nitpicky for a lot of random nitpicky record reasons. It's like the Guinness World Records, the most time spinning a plate on your nose, the most time spinning a plate on your ear. I guess they're different, but really it's spinning a plate on your body. So, they really are trying to do better. They're trying to just launch more. And things like SpaceX and the Crew Dragon and the upcoming Boeing launch, and if that's successful, will allow more opportunities for launching humans, which means more opportunities for, say, ESA astronauts to go up. And they want to make sure that there's more than just 2 who end up going up into space.
And the whole process is going to take around 18 months of selection processing before training begins.
Yeah, look, lots of rounds. And I always like to say the first round of astronaut application is really just to sort out the ones who you need to actually then look at. Because no offense, because they are open to everyone. And that's the great thing about it is as long as you have the citizenship requirements, you can apply. Obviously they get lots of interest, which is great. A lot of people just aren't clearly suitable given what they're looking for. Given they want some combination of scientific and engineering and or medical and or engineering and or flight experience, and preferably a bit of a few of those categories. It's quite clear that when you start looking at the early applications, there's a pile you really need to pay attention to and a pile you can say, thanks for applying. Here's your letter to say thank you for applying to the astronaut program. And then starting to go into the round 2 of the nitty gritty of those applications, which are still going to be in the thousands.
And lastly, this week, Brad, we love a good bit of Aussie influence news on the show. Astronomers here have discovered the first black hole is bigger than thought.
Yeah, so Cygnus X1 which was a supermassive, or not even, sorry, a stellar mass black hole. So one of the smaller black holes discovered in the galaxy. In fact, it was the first one, as you said, discovered black hole back in '64, I think it was. And they started to see that it was really sucking away and messing around with a neighboring star, a blue supergiant. And so since then, Cygnus X1 has been hugely studied because it's relatively nearby. It's thousands of light years instead of millions to billions of light years. It's also a stellar mass black hole, so one of these smaller ones, as opposed to the supermassive black holes, which reside in the centers of galaxies, which are easier to find given how much they do. So it was a really interesting event, and so it's been studied a lot. And some new measurements suggest that not only is it a bit further away than expected, but because it's a bit further away, it's a bit heavier than previously measured.
And this change in distance has changed around 1,200 light years. The new predictions say it's about 7,200 light years away. That's still pretty close, and it's throwing out the scales, as you say, this change in how heavy this thing is.
The updated technique is using something called parallax. So parallax is a very common technique in distance. I use this for measuring stars in the galaxy to anchor how we measure the faraway universe using the Hubble Space Telescope. And it's using trigonometry, that thing in maths that you say you never have to use. There's a few of us who actually use it a lot, surprisingly. And it's a very useful trick. So, year 10 maths can be fundamental in astronomical discoveries. I think that's the really cool thing here. Now, using some radio telescopes, they were able to use radio telescopes to do this parallax measurement. And because it's trigonometry, it ends up being actually one of the very most accurate measurements you can do, as long as you know something really well. And we know something really well in space, and that is the distance the Earth is from the sun. We have a really good measurement of that, really accurate. And so you can use that anchor to measure how far away something is using trigonometry. Essentially, if you hold your finger there and if you blink your eyes, well, to me, my finger is moving relative to my camera or the screen here. And if you do the same, if we know the distance between your eyes, you can measure how far away your finger is. It's pretty cool technique. Now, at some point, the further away your finger is, you don't see a distance or a difference, so it stops. The closer it is, the bigger the difference. So it's a really simple way of doing this. And now that the technology in the radio wavelengths has been able to do this interferometry and this parallax, they're able to get this very, very accurate measurement. And as you said, ends up being a bit further by about 1,200 light years.
Now, there was an initial study done in 2011, but that one didn't map out a full orbit of Cygnus X1 and its companion. So redoing that data using parallax, using some trigonometry, it's sort of sorted out these discrepancies and given us, as you say, a really good baseline for where X1 is.
That's right. And because if you know exactly how far, or better how far this object is, you can then use it to get a better measurement of its intrinsic properties like light, energy, and in this case, mass. Measuring that it's now about 21 times the mass of our sun, up from I think it was about 12 or 15 times the mass of our sun previously. So able to get that it's a bit bigger than previously measured and a bit further away than previously measured.
And we've sort of changed what we're thinking about stellar mass black holes as well now, because it seems like they're less likely to lose mass, and the density of them is really kind of set by how big the originating star was.
Yeah, one of the questions is finding the thing that creates the stellar mass black hole. So it's some sort of massive star that collapses in on itself and creates a black hole. It needs to be bigger than the ones that explode and create neutron stars, but not so big it does something else. So there's this regime, there's this range where we think these things happen. And what it appears to be is that mass that collapses in on itself really sets the size of what it can be and the weight of what it can be. And it doesn't bleed or lose mass that quickly, which is the case here. So it's not accreting or it's not losing that mass into space. And therefore, it's a pretty good, safe measurement of what created the black hole, and therefore what is the black hole and what is the source of the black hole.
Brad, another big week of Talking Science. As always, it's great to pick apart the stories of the week with you. We're going to do it again next week. Go answer those emails.
Yeah, thanks.